Throughout the world, pipe jacking and micro-tunneling are becoming increasingly important for the installation of sewer pipes and service lines. The Herrenknecht AVN series introduced in this film has been deployed successfully on every continent. The advantages of the pipe jacking and micro-tunneling process are evident. Especially in urban city areas, pipe jacking causes minimum disturbance along the construction route, so there is virtually no disruption to the flow of traffic or any impact to the local economy. In contrast to conventional methods in such construction projects, pipe jacking and micro-tunneling has an environmentally friendly method and helps to conserve protected landscape areas. The following animation shows the installation of new sewer pipes within a diameter of 600 mm in an urban crossroad with dense traffic. The whole construction site can be located in a way that only one lane is affected. In our example, 150 meters of sewer pipes are to be jacked from the launch shaft to the reception shaft. At the first stage, the area around the starting shaft is cordoned off and the traffic is diverted to the remaining lanes. Due to the compact design of the machine and the small diameter of the starting shaft, there will only be minor disruption to the traffic flow. In this case, the start shaft consists of a round shaft of reinforced concrete with an inner diameter of 3.2 meters. The compact jacking frame is then placed into the starting shaft, and the slurry discharge pump is mounted on a platform adjacent to the jacking frame. The operating container with the control panel and the hydraulic power pack is located on the top rear side of the shaft. A pipe stock is then established and maintained in front of the shaft to feed the shaft crane. The slurry feed pump and the slurry discharge pump are connected to the settlement tank to form a closed slurry circuit. The AVN 600 machine consists of several segments. A sleeve shaft with 3 boreholes connects the cutting wheel with the drive unit. The mix of crushed material and slurry water is sucked off through these boreholes by the discharge pump. The conical crusher situated in front has reinforced crushing bars and is provided with nozzles to inject the slurry water. The sleeve shaft, which is connected to the cutting wheel, is driven by hydraulic motors. The sleeve shaft is seated in a tapered roller bearing. 3 hydraulic motors transmit the rotation via the gear rim to the sleeve shaft and the cutting wheel. 3 steering cylinders enable the operator to correct the direction of the tunnel boring machine, as well as control the alignment of the machine in curved drives. Therefore, the position of the cutter head is continuously updated with the help of the laser guidance system. To ensure AVN 600 has a smooth method of excavation, the machine has 2 integrated water circuits. The standard circuit supplies slurry water to the annulus via 5 hoses fixed to the inner side of the bulkhead. Several boreholes branch off from the annulus, which supply the chamber situated behind the conical crusher. The slurry water is continuously pumped through the conical crusher chamber, sucked off through the boreholes of the sleeve shaft, and transported back to the settlement tank by the discharge pump. A second hose supplies the high-pressure nozzles used in the conical crusher. These nozzles avoid clogging and agglutination in the crusher chamber in case of cohesive soils. They cut the clay in the crusher chamber with 250 bar water pressure and consequently make material transport easier. There are also 2 nozzles that are directed to the front part of the cutting wheel. This totally depends on the geological situation, as the number of nozzles can be increased. The water coming from the nozzles is mixed with the water of the slurry circuit and the excavated material. The whole mix is then transported to the settlement tank. The cutting wheel excavates the material at the tunnel face. In the crusher chamber, the material is grinded down to the appropriate grain size by the spokes of the cutting wheel, which operates in the same principle as a coffee grinder. Large stones are crushed by the discs of the cutting wheel. Sometimes, fragments are being displaced to the surrounding soil. stones, attaining the crusher chamber through the openings of the cutting wheel, are crushed by the reinforced conical crusher and the spokes of the cutting wheel, and afterwards transported together with the slurry water to the surface. The material is picked up in the slurry circuit and transported to the settlement tank through the central slurry discharge hose. The slurry feed and discharge lines are passing through the jacking pipes via the jacking frame up to the surface. The slurry discharge pump removes the excavated material and pumps it up into the settlement tank, which consists of 2 chambers. At first, the excavated material is pumped into the rear chamber, where it settles due to gravity. The overrunning water is collected in the front chamber, from where the clean water is sucked by the slurry feed pump and returned to the slurry circuit, thus creating a closed system. The product pipes are lowered into the shaft, one after the other. The jacking frame works in 3 stages. After approximately 1/3 of the maximum jacking stroke, the jacking arms return and the main thrust ring of the jack can advance further. After jacking the product pipe, all supply lines, such as hydraulic hoses, are disconnected. The jacking frame is returned to its original position and the next product pipe is lowered. This procedure is repeated again and again until the whole drive length is completed, reaching the reception shaft. Crossing pipes and buildings can easily be overpassed or undercrossed with this technique. Thus, the machine arrives in the reception shaft exactly at the planned coordinates. The drive is continuously monitored by a laser guidance system. The laser itself is positioned in the starting shaft, meeting the laser target, which is installed behind the cutter head. The laser beam determines the reference axis. The laser target identifies any deviation which may occur. The coordinates are transferred to the steering computer in the container and visualized on the screen. Any deviations in position can be corrected by adjusting the steering cylinders at the push of a button on the control panel. The length of the tunnel is recorded by a metering wheel. This information is transferred to the control panel and allows the operator to determine the location and direction of the machine cutter head at any time. In our example, the total of 150 meters of new pipes could be realized with only a minimum of disturbance in a sensitive infrastructure. The conventional open laying of pipes would have caused major disturbance and annoyance for traffic and the residents. Herrenknecht, being the leader in technologies for mechanized tunneling, has both the know-how and the experience to realize every tunneling project. Throughout the world, the company, with its headquarters in southern Germany, is the only supplier offering the entire range of tunneling machines, with diameters of 100 millimeters up to more than 14 meters. Hard rock TBMs, EPB machines, mix shields, and machines with partial face excavation, as well as pipe jacking and HDD equipment manufactured by Herrenknecht, successfully realize mission breakthrough all over the world and in every geology.